Sigma, sigma boy, sigma boy, sigma boy. Wow, look at this sigma guy. We start at 1 and end at 35. Now, normally with a nice sigma notation, we would just add a bunch of stuff up, but not here. I'm going to use two shortcuts. Shortcut number one is if I have just a constant, right, and I start at 1 and I end at some number, the shortcut is I could just do c times that number that I end. That's my shortcut. That's going to help me take care of this -2 part. Now, the part that's going to help me take care of k is if I start at 1 and end at some random number, I'm going to do n times n plus 1 all over 2. So those are my two shortcuts, right? How am I going to set this up to make it look like that? Well, watch. I'm going to first do the 5k and rip the 5 out in front of the sigma. Okay, so I'm allowed to do that. I'm allowed to do that. That lets me focus on just the k. Then I'm going to subtract the sigma notation, k equals 1, ending at 35, of 2. Now these guys look more like these guys, and it's not that bad. Okay, it's not that bad. Should have put a k there. It's not that bad. So, all right. 5 times. Now let's use that where my k is just a k. I'm going to have n, which is 35, so 35 times 35 plus 1 all over 2. Minus, and then I'm going to use Cn. So my C was 2, and my constant is n, or my ending is 35. So I'm going to have that. And now it's just a PEMDAS problem. 5 times 35 times 36 all divided by 2 minus 70. All right, let's move that over here. 35 times 36 is 1,260. So divide that by 2. I'll get there in a minute. Minus 70. So dividing that by 2 is 630. 630. Let's make it a little bit larger because we're dividing it by 2. Minus 70. That is going to be 3,150. Minus 70 is going to be 3,080. And that's how you do it. Sigma notation.